You should wait for 5 minutes. Start sharp at 5. 5, 5. So it's 5, 5, so we start now. So first of all, we will go with the assignment that we submitted, last week on August 9th. So this is the first question. We are going with the first question now. This is the assignment problems. So carbon percentage in what they are asking here, percentage of carbon in cast iron. Here we are asking for cast iron. So for cast iron, it is less than mild steel is wrong statement. You know why it is not less than for cast iron. Not should not be less than mild steel have less. Cast iron have more. So 3 and 4% is again correct. Less than 2% is again for the speeds, not cast irons. More than minus 2 is correct because minus 2 are less. More than 4% is wrong because more than 3% will be something else. It's not cast iron. It will become more better than cast iron. So it's not cast iron. No, 1 to 3% again is around 3. So 3, 4. It is given in the theory also. So 3, 4, 3, 4 and more than minus 3 will be a correct answer. So these two will be your correct answers. So your C will be your correct answer. Okay, so we're moving for the second one. Cast iron is used for late beds. So we are looking for cast bed, cast iron. Why cast iron is used for late beds? So they are asking why you are using actually. Primarily because of it is good in tension, bad in compression. So it is a cast iron. So cast iron have a property of compression because it is brittle material. No, cast iron is a brittle material. So it can't be good in. So in case of tension, it can't be good in tension. So it's fairly good at. It, but in case of tension, it is not possible. So in tension, it is not possible. Okay. Okay. So in case of tension, it is not possible. Okay. So it is a tension, and in case of tension, this will not be possible. Okay. Because it is a cast iron, it is a bitter material, which can't work to tension. Both tensions and compressions. There is not working in tension. So it is actually wrong. Good in compression is correct answer because it is good in compression. That's why you can go as a very good it will absorb all the vibrations. Cast iron should will absorb all the vibrations that came in the lift into the forces that are acting in the machine, so that the vibration of the so that vibration will not reach the tool or mostly the tool or not the bed. So it will act as a damping mechanism. So mostly cast iron is used as a damper because it goes in compression, it will act as a damper. And the other things like body tension is other towards brittle material. So body tension is again wrong. So only the second answer will be there, that is good in compression because it is used as a damper. In the left bed, it is used as a damper so that the motion, the vibration in the tool, vibrations are caught in the two levels which are in the contact. So due to the vibration, the chatter will be generated at this moment. The chatter circulation will be there. So due to which there is a lot of vibration. So that vibration will be damped by the tool. It is not going to the bed. So again, it vice versa. That vibration from the bed will not go to the tool even. So this can be done using. So we are using the cast iron for the less bed. So bed means actually we are using for reducing the vibration, or you should absorb the vibrations in the case of bed. You should absorb vibration. That's why they are made up of cast iron. Absorb the vibrations. Where the other carbon content in the steel increases. What happens? The hardness increases and the ductility decreases again. This is a inverse property that hardness will increase is the inverse property actually. So if hardness will increase, then ductility goes down because it is hard to ductile. The case hard to make it ductile. So that is the case. Like inversely, so that is the increase in hardness and decrease in ductility because uh, with hardness it will become more brittle, and as it will become more and more brittle, the ductility will be go down. It is obvious because with more hard it will become more brittle, and with more brittle ductility will go down. So your hardness will increase. And why the hardness is increasing? Obviously because you are straining as the carbon content is increasing in a crystal lattice, that is if this is the iron atom. What we are doing actually, we are increasing carbon. We are producing more and this not. We are actually using more and more carbon due to which the more and more straining will happen inside it. Due to more and more straining, the hardness will be increased, and due to more hardness, the ductility will goes on decreasing because we are actually getting overstressed. So it is actually stress. So due to which this material will be actually stress. It will be induced in stress due to these things. The ductility will go down because of the increase in heart rate that I already told that. How the hardness will create the problems that it is slight noise here, so this slight noise will not come. So yeah, so this kind of either atoms and what we do in case of steel, the carbon atoms will be placed somewhat inside this and somewhere display like each station we are placing. As more and more atoms will be placed, the more and more strain will be there. So more straining will be there due to which the hardness will go down increasing. As the carbon content increases, and due to that, ductility goes down decreasing. So the hardness will increase, and ductility will decrease. So that is both hardness and ductility. That is not possible. This is absolutely not possible. You know, the hardness decrease and ductility will increase. Hardness decrease, ductility will increase. That is not case because we are actually increasing we are increasing the number of carbon content. So we are increasing the number of carbon content due to which the straining will be more and the hardness will increase or decrease. Both hardness and ductility will increase again cross purpose. The answer is only this increase in and ductility. Hardness is increased and ductility will decrease. That is the correct answer for this. Okay, so chromium alloy is alloy steel. In alloy steel improves corrosion resistance, strength, wear resistance, hot hardness, everything that is most added for corrosion resistance only. So everything strain, wear resistance and hot hardness, everything is gained by using chromium due to change in the crystal structure of the steel atom with strain and oxidize also due to it also has oxidizing properties. So it oxidizes to form a layer. Again, it will have a hot hardness is high. That all are the correct. And hot hardness is high again the corrosion resistance because of this, the strain will be because it is straining, we are selling the material, hot hardness, wear resistance also because of the hardness only. Those all things due to because of the hardness, increase in the hardness because we are what we are doing, we are increasing the topic, the alloy material due to which the more straining will happen, and due to more straining, only the there will be relatively harder materials because of the more strain inside of crystal structures, it will be harder. So for deforming material, we need more strain or scratching, it will more energy. That is called a strain hardening. Something simply it will happen. It will more strain hardening will happen like wear resistance or strain. All these properties will happen. So all of the above is correct answer. This they were given in the slides that you can read. That is everything will happen to the proving. And for that, actually, the research must be done. So what property change has been observed. So these things, when we see in the research that things are actually increased, we can put it. So these all the properties are gone from the research, and we got this from research papers. Various researchers have done these things. So we will get a correct answer for everything. So these properties are checked with everything in a proper lab conditions. So from that we will get from these papers we will get how these things will be increasing and we get this increase the reason why it is increasing once it is accepted by everyone it will put into publication that okay this is the correct answer so everything is mentioned in the slides that all are correct so and these all properties are finally happen this everything is done when you add a chromium in alloy steel so all of the answer is the correct answer so again, go to next. Aluminium and its alloy are widely used in the aerospace industry mostly because of their aluminium mostly is high, means its weight is less, density is less. That's why its weight is less and the ratio is high, strength is high. So due to which strength is high. So density and weight is less. These things are less, and only strength will be high. So because of these things only, because in case of aerospace, the strength is high in aluminium and the density is less. So it is. So due to this thing only, uh, because so the density is less and weight is high. That's why weight is low, density is low. That's why weight is low and the strength is high. So for more less weight, we are getting more strength. So here we are actually getting more strength because more strength we will get with less weight. And due to because it is aluminum is like that, because of the high strength and good weight ratio of the aluminum, what will happen in aerospace? This will reduce our fuel consumption because we are reducing the weight. We are getting the same strength, but we are reducing the weight. So due to reduce in a weight, we will save our fuel, and the fuel there is very costly in case of aerospace application. So reducing the fuel will automatically increase the efficiency of the machines and the cost or the profit for the company. So this is very again important for us to high to strength ratio to be is, and it is very important in case of aluminum or in case of aerospace applications. And the aluminum has that this property, so we mostly use the aluminum in case of mostly used in aerospace industry because they are required such kind of properties. That's why use high strain to weight ratio. Again, the use of machining and forming is not the case because there are many other why to use it. Aerospace we need strength and both. It is not about just forming and those things. We need strength also because in aerospace, so it is already in air. These things are not that much, so we require strength also and require weight to reduce also. So strength must be high, weight pressure will be low. So for that case, aluminum is mostly used. Resistance to atmospheric corrosion, attack to certain. These are not important things here in case of fuel. So atom of corrosion and attack by certain chemicals, high electrical conductivity. This will now there are other materials also used for these properties. Aluminum specialty of the aluminum is this only. So that's why you're using. I need to mention that resistance to atmospheric corrosion and attacks. I think it is oxide. Aluminum is not that much resistant to atmospheric corrosion. We have to do to reduce from resistance. So this is only the reason why it is mostly used because of the high weight to weight ratio. We reduce the weight. That's it. Reduce the weight and reduce the fuel for the same strength. Because again, I told you the strength is an important role. You can reduce strength. That's it. So material that is light as aluminum but hard and stronger than steel is called. It is given in the slide that it is specially engineered material that is silicon, aluminum, oxygen, and nitrogen. So this specific material is prepared for applications required that is stronger than the. It is mentioned stronger than the steel and lighter than the aluminum and stronger. It's just special material that is special material that is engineered for a specific kind of applications basically. So this is specifically designed for specific kind of applications only. So this is the material which is on this, which is lighter as aluminum. Silicon is a lighter than aluminum. Not silicon. Ceramics is not like and stronger than steel is different. It is good in compression, not in tension. These are hard hardness and where this is good in this tension, not in this. Composite material again there is composite. Which composite material? What is composite material? No, there is no meaning. Carbides are again this kind of ceramics like concept is there. So only cellulose is the material. So which is actually which is engineered, which is engineered actually for specific applications. Is mentioned here. So cellulose is the correct answer. So, so in fiber composite, ductility and toughness are provided by the ductility and toughness in fiber composite. What the property they are asking is more important over here. Okay, what the property they ask is more important. Which property they are actually asking for? Ductility and toughness. So we have to go with ductility and toughness. So ductility and in case of fiber composite, we are using fibers which are elongated. So this will our fibers will help in the elongation, not in ductility and toughness. So ductility this will not help. Fiber composite ductility is actually used for tensions. So the fibers will not help in increase the ductility. Or anyhow. So what will help? Only matrix will help. And ductility and toughness again both. In case of fibers are only for getting a tension, okay, for a load, for tension, to increase, to have a more tensile strength. That's why you're using the fibers for getting more tensile strength. Okay, not for ductility and not for ductility like elongation, but not we are not getting for not getting for ductility specifically. So Only the matrix material which is present over there can handle the ductility. Only this thing can handle the ductility and no other thing. So mostly this thing only handle that. This thing only will handle ductility. This thing only handle ductility. This thing is matrix. So fibers, I told you, this for tensile load, tensile strength, not for ductility or toughness. So matrix is only correct answer. That word resin, these things are not. Resin is not in polymer. So resin is actually the waste part of it. It is not the final product. So it is pre manufacturing. Using it is in pre manufacturing, not for after manufacturing. Not as a final product. So only this will be my correct answer. Okay. Material that is unable to deform plastically without fracture. It's called as we are actually talking about stress strain curves. So what is about the curve is like this only. It will not go over this. It's only up to 8 points and we are to fracture. So this will not be curved like this, but mostly the ductile always the ductile curve. This is mostly we are talking about brittle because we the material that is unable to deform physically without fracture. So in fracture in ductile cases the fracture will happen. So sorry. Yes. In brittle cases you know how the stress strain diagram will go. They simply going like straight and this is going like there will be no fracture at all. Directly brittle. So without a fracture, in each case only the brittle material is the correct answer because it is not deformed at all. We have to be not deformed plastically. Uh, as mentioned, it is unable to deform plastically. Only brittle materials are unable to deform. Ductile materials can be deformed before fracture. So these all are not correct answer because high hardness material, high strength material has no meaning over here. Only ductile and brittle material has actual meaning in this case, and the ductile material actually have can be plastically deformed. So this is not a correct answer. Only the material which is unable to you mentioned unable to be deformed. So only brittle materials are unable to deform. So this will be only your correct answer. Brittle materials. Okay. So time question. Maximum load experienced during the tensile test divided by original area is tensile strength is very basic. So right now we are solving the assignment problems which is submitted from 9th August. This is the very simple tensile answer because it is original area and two stress is not it is load experienced during the tensile test divided by original area which is tensile strength. It is just this all the chemical terms. So increase in the strength that occurs in the metal when they are strained is called increase in the strength that occurs in the metal when they are strained is called as uh, increase in the strength that occurs in the metal when they are strained is called as strain hardening. So it is again very simple, very simple. You can say the maximum load experience during the tensile strength divided by original area tensile strength. Yeah, two stress may be anything, not a strain strength, is tensile strength. Maximum load is tensile strength. Okay, this is not converting stress or anything. These are all basic terms. So maximum load experience will be tensile strength. Okay, so increasing the strength that occurs in a metal when they are strained. So I told you when they are strained, there is an increase in the strain. Okay, so why? Because of the strain hardening, which is also called as work hardening. So how the work hardening will happen? It is called as also work hardening. You know why the how the work hardening will happen? You know this because of the straining. The material getting strained due to which the more force will be required to strain it further. So it is called a strain hardening effect. That will explain last week. You know this alone. It is called a strain hardening effect. So this strain hardening effect it is occurs in material that strain is called. Okay. So due to this strain hardening effect, only the material getting most increasing strength. Plastic deformation, they are doing the similar deformation is not a case. Increasing strength is not happen. Heat treatment again is no. There is a different case, but occurs in metal when they are strained. Heat treatment and strain are completely different aspects. So heat treatment is not in case of strain materials. Okay. So only the correct answer will be high strain material, high strain, strain hardening, or high strain hardening. Okay. In the region, the plastic region of the stress strain curve for a ductile material or metal. What you are asking, the plastic region of a stress strain curve of a ductile metal. So you are actually in plastic region now. That is more important. Where we are. So you need to think that where we are actually. We are here. We are in a plastic region. So you need to think that. Okay. So first thing that where we are. We are in the plastic region right now. So this is ductile material. You know. Right now we are. You cross the end point, upper end point, lower end point. We are going here in plastic region right now because mostly from here also. But there is again lower end point also there. So we were different phenomena. So right now we are plastic region. So coefficient the stress is proportional to strain, again this is not. This is up to elastic limit only. To this limit only it will be happen. So this statement is definitely wrong. Okay. Why you move the answer? Why this statement is definitely wrong? Okay. Because the strain hardening, stress is not proportional to strain. Okay. Up to this only it is happening. We are right now in this region. We are active in these regions, these things are possible. So if in a friction is constant again, these things are not possible over here. It is giving in term coefficient of friction because after this point it is we have in plastic region the coefficient of friction is not, you can have nothing to go with it. So it will be constant again as a false. It will not be anything is not constant because it is the material is going to unstable state and if it is an unstable state you will not have anything. So coefficient of friction will be a problem, will not be constant anymore. So normal stress is equal to the shear area, shear stress. Normal stress is equal to shear stress is not a concept. Where is normal stress and shear stress in. So in plastic region, the normal stress is equal to shear stress again. The cubic in terms of normal stress and shear stress is equal to means it's not at all possible. So what is does not proportional is correct answer only. But these things are will be in terms only. So to deviate you from the actual answer, that is because normal stress is equal to means in no case that is share normal stress is equal to very specific terms. It is very well for specific problems. It is not generally equal to everyone. So it is again a wrong concept because it is you need to see the how the actual value is. You need to work with how the things are actually. So we have to actually go into the problem. It is not true for every general problem. It is a very specific problem. It's not a consumer. So this is a wrong concept of this part. Only this is because does not remain proportional is a universal. That in that area it is not does not remain proportional is a universal concept. So this will be a correct answer always. Okay. Does not remain proportional is the correct answer because everything is against is not viable at all. So 60 millimeter long mild steel wire has been elongated thrice by 0.5 millimeter each time. The true strain in this case, you know the formula of true strain actually. This is our true strain which is equal to, we know this is Ln which is L final divided by L original. We know what is L original now. Okay, we know what is L original. We know it is Ln, we know what is L original. What is L original? Sorry, L final it is. L original we know that is 60 millimeter. Right now we need to find L final which is more important. So it is one version 60 plus 0.5 into 3 because it is divided by thrice, elongated thrice. So if we find the answer, it will be 0.025. Simple using calculator, you can do calculation. This is the true state. This is the answer for this. That's it. Again, the plastic deformation in as metal occurs on planes. Which planes you are asking? That you have a crystal structure like we have normal crystal structure. You have that level crystal structure, and what you have asked here is you have a crystal structure, and what they ask you is that which planes. The planes are furthest. The correct answer that lowest atomic density is wrong answer because it should be highest density to get less resistance. So this will be wrong concept where the resistance to slip is minimum is again is correct, where atoms are densely packed is correct, and closer they are closer to each other. That are closer to each other now because it's contradictory. This is contradictory. Both of them are contradictory. So this is where this is always wrong. Closer to each other does not mean farthest apart. Closest will increase the resistance. Okay, that is the case. In this case, the resistance will be increased. You know this right? Resistance will increase if you are close. So you have to follow the minimum resistance path only. So you have to go with minimum resistance path. So for minimum resistance, you have to go with minimum resistance path. Minimum resistance path. So for getting a minimum resistance path, uh, closer should not be case will farther. That are orthogonal to each other again is wrong. Orthogonal to each other is perpendicular or something that is not the case. So only combination is first, third, and fourth. So this is A is the right answer. So in shear stress required, theoretical removing material from our workpiece has been theoretically calculated 39 point. What is the answer? Is 39.8 Newton per meter square. The shear strain of that material. We know the formula. Like for maximum, theoretical is like theoretical, not maximum. So theoretical, you know the formula that is equal to G by 2 pi. This is for theoretical. We calculate by using that analytical calculations. So from that we get the tau that is for getting the theoretically for removing the material. So for starting the material removal process, what will be the shear stress required? So we calculate the theoretically which is G by 2 pi, and we know this is the G which is 39.8 into divided by 2 pi will be your answer. So this is not a G. So the G will be your this, and this will be your 39.8. Okay, this is not a G. G this is the water of what they are given from the it has been given theoretically calculated to be they given this value maximum. Okay, so these so what they give the maximum value over here. So they actually give you the maximum value. You know the formula G by 2 pi, and from the G by 2 pi you just need to simply multiply it. So 39.8 into 2 pi will equal to some 250.1. Okay, so this will be correct or correct answer. What we will do? Just multiply it. Okay, so we have to consider what is this. This has been theoretically calculated. This is not this is the stress actually. The theoretically calculated stress that is required. It is not shear modulus. So they are asking the shear strength. That is shear modulus they are asking. So you might confuse. So be very critical while writing the problem is more important. While reading it, not writing. While reading the problem is more important that you have to get what properties has been asked and what property is not asked here. So okay, so for our workpiece has been theoretically calculated. Okay, for the theoretically calculated value that is tau. Okay, and the strength is G. Strength will be G and the theoretically calculated will be tau. So in the formula is equal to tau is equal to G by from this mostly what we have this value and this value that is we try to find out this value, find this G. So that G will be simply equal to Q into 2 pi. Okay, so multiply it. Distance of the tool that is plunged into workpiece is called as depth of cut. Okay, depth of cut is it is how much depth of cut you are actually providing to the workpiece. So that is what we actually go we call as this is our workpiece. So this is our workpiece. So how much penetration it actually has. So how much penetration it actually has inside this it will be your it's not straight, but how much penetration it actually has. That is the distance the tool that is plunged into the workpiece. Plunge into the workpiece that is actually how much depth you are actually plunging here. How much depth you are giving over here to the tool. Okay. So how much depth you are actually giving here for the tool over here. This point is actually depth of cut. this will be your depth of cut. Uncut chip thickness is again is not to field, is not going that direction, and width of cut is again not so depth of cut was only standard formula, standard definition is there for that. So when it is plunged, it is called as step. How I show how it is get plunged. So here we are actually plunging it. So this will go inside this and that will be murder. So here we are actually plunging it. Here this part actually we are plunging it. So plunging it means so we are actually are plunging it. So plunging it that means actually we will have the depth. How much the depth it will cut. So this is the depth it will cut. So the material again we reduce to this something like this. In level 2, so up to these two molecules, where is the depth of cut. This is depth of cut. Okay. Depth of cut means what this is after machining. After we do this depth of cut, so after machining, this will be your workpiece look like. Because it is depth of cut. Okay, so correct answer will be your depth. Correct answer will be your depth of cut. Okay, depth of cut. So for a machining process that with a field of 0.4 millimeter per revolution, the uncut chip thickness has been found to be the uncut chip thickness means T1 is given to you uncut chip thickness, and the field is again given to you field. F is given to you, field is given to you 0.4 millimeter per uh, per revolution, and the thickness is given to you. This uncut chip thickness 0.2 millimeter. What you need to found side cutting of the cutting tool. So you must have side cutting in the cutting tool will be used. So we must know the formula for it. So the formula for it will be so T1 that is T1 is equal to field into cos of your side cutting angle, side cutting edge angle. So what that to do? So it's simply T1 by F, which is equal to cos RS. So after doing that, to know the value of T1, we will be 0.2 divided by 0.4 into the cos we came here is cos inverse of 0.5. So we know the answer 0.5 of this is direct calculation. Cos 5 means cos inverse of 0.5. This will go 1 by 2 to 0.5 will be 60 degree. Right answer. 60 degree. Okay. So for orthogonal turning process with the tool will be 60 degree with 60 degree side cutting edge angle. Tool with 60 degree side cutting angle and 2 millimeter width of cut. So what is the width? We know the width is equal to 2 millimeter, and our tool angle that is after cutting the side cutting it is equal to 60 degree. So what we need to find out over here is the depth of cut. So we must know the formula. Depth of cut is equal to what we know the formula for depth of cut. We have width of this is equal to this depth of cut divided by cos of our angle, that is side cutting edge angle. Okay, so what we have width we have RS we have. So what we do is simply multiply it. D is equal to W into cos of RS. Okay, so we know W2 into cos of RS will be 60. So from that we know what should be 0.5. 2 into 0.5 will be 1. So this is our answer 1. Okay, 1 in millimeters. We mentioned here that is 1 millimeter. Okay, this is 1 in millimeters. Strength of the tool cutting edge in strength of the two cutting edge in orthogonal cutting in comparison to that of the oblique cutting is, you know, in orthogonal cutting the entire edge is actually cutting. You know the fact that the entire edge is cutting. In oblique cutting is a point tool, which is actually what is actually happening. It is gradually loaded. Okay, though it is gradually loaded, but only point is active. So material here is less. The material which is possible for it will be less. Okay, material will be less. But in case of material will be less here. Okay, this case material will be less, but here the complete material is available. The entire material is available at the back side. So this complete material will be available for shipping. So entire this material will be available. So I should show this as a dotted line because outside. So this part is visible, this part is visible, this part is visible. This is back side. So entire this material is available to this. Okay. So what will be the answer? Less. Let's be the correct answer. Means the orthogonal cutting in comparison to the oblique cutting. The orthogonal cutting it is less than the oblique cutting. Why? We know the material is there, everything is there, but in this case, how it is, we need to work with how it is loaded. So this again, the this complete strength is available for a tool. This is how the material will work. But the entire edge, see the entire edge of this will be acting. With this material, the entire edge will be acting. Okay, as the entire edge will be acting, so more force will be required, everything required is more. But here only point 2 is acting, and this it is gradually loading. So strength here will be more because the gradual load that we are applying to that the gradual loading. Concept of gradual loading. In case of oblique cutting, there is a gradual loading. You know, it is oblique cutting. The loading is gradual. So it is inclined, including inclinations we get provided. Here it is inclined. And this in this case there is no any kind of inclination is provided, it's purely straight, so the strength is less. System is cutting edge. Okay, strength of this cutting edge is less because it is directly bombarded, directly entire edge will be happening. And here the edge is gradual, the point load will be increasing, is gradual not direct. So due to this graduality in oblique cutting the strength is high, and in orthogonal cutting the strength is less. Okay, what we are actually in orthogonal cutting in comparison oblique cutting. So due to the oblique cutting has gradual loading, it is have more strength, and but the question is asked for orthogonal cutting, so this is less. Okay, you need to read question correctly. So it is asked for orthogonal cutting. So in case of orthogonal cutting, it should be less than oblique cutting. So this should be answer. So repeat relative less value of two break angle. So two big thinner relatively less angle means this is our rake. No, this particular rake angle. This will be your rake angle. You know, this will be your rake angle. Okay. So what they ask you is less value of tool rake. So this value is less. This rake value will be less. So simply what will this kind of tool will be available to you because of the less tool. Because of what? Oh, it's like same, but I have to change for more. Okay. This kind of so this will be the rake angle of the less over there. So you can see this will be your rake angle. With less angle of rake angle, the discontinuous chip will be formed, and it will be we call it mentioned here is correct. Tool becomes thinner. You see, which is thinner over here. With more rake angle is thinner, with less, so this will be wrong. Okay, you know this will be wrong. This will be wrong. Okay, discontinuous chip will be formed in case of less value of tool cutting angle. Discontinuous chip will be formed because it will get bend more. Okay, to bend very large, so it will cut here somewhere. No, because bending will be high, so it will cut differently. So this curvature will be formed, and the tool becomes stronger. You know the area is available here, more area is available here for cutting actually. Yeah, presently this is only the area available. Here, the entire area is available. See how much area is available over here. Just due to this much area is available for us, the tool becomes stronger. The build-up it does not form. Yeah, because it will break as a discontinuous chip will form. How the database will form. I think it's not contradict to statement completely. Okay. Tool can dissipate because you see there is more area, so dissipation will be good. Here the area, then dissipation will be bad. Okay, so again because we are having a less rectangle, so it's correct. Continuous chip will build up. There is no discontinuous chips are formed. The continuous chips without answering again. Okay, so 1, 3 and 5. 2, 3 and 5 is the correct answer. It is B will be the correct answer. Okay. So again, the buildup is doesn't form at lower to medium cutting speed. No, we know the graph for that. Okay, we know the graph for that. Is there in the graph. We will after that we see that graph how it will happen. Somehow you will fill in again, it will fill in again implement. Okay. For extremely higher case only the buildup edge will not form. Here we are having a higher cutting speeds. Here the receiving cutting speeds and surface, both for surface. Uh, for my video is not cutting. So cut lower to medium cutting speed is not our case. Okay. Lower to medium cutting speed because it is in this zone. This zone here is the formation of buildup edge. Actually, this is zone where buildup edge will form because here temperature to the recrystallization temperature will be formed over here. Below recrystallization temperature will form again. So the buildup edge will definitely form with the high because of the high speed and lower to medium, which is similar to high because it is up to medium range. Temperature is not a big recrystallization temperature, so buildup edge will form over here. Small field again, this is not because for the small field buildup edge will form temperature below the temperature of the temperature below the temperature of recrystallization. Again, this is correct. At because after recrystallization, the growth will be the new grains will be formed. You know this fact that after recrystallization, the new grains will form. Okay, so after the recrystallization or the temperature will take the recrystallization. So after the recrystallization, the new grains will form due to which the buildup edge will not form because there is it will take another simply because the recrystallization material becomes slightly softer. The hardness will be gone from the material, it will flow, so it will not stick to the material. So the stress will be relieved from it, and due to which there is a softening of material and it will flow. Okay? There is no sticking or inert surface will not happen. So the material will flow due to the increasing temperature. So does not form below is wrong. If it is above, it will be correct. So it is below, it is wrong. Okay, below word is wrong. Consider even below word is wrong. That's why the entire C will be wrong. Okay. The higher cutting speed, the recrystallization temperature will be reached. Okay, the recrystallization temperature for what we are talking, the recrystallization temperature for what? Okay, recrystallization for workpiece material. Okay, workpiece recrystallization temperature for workpiece material. Okay, will be reached. These things will be reached, and due to which when we are reach to the recrystallization temperature, this will be reached and we can actually cross this. So this to which the recrystallization will happen and the material becomes softer due to which the build-up edge will not form. Okay, will not form. This will be a correct answer. So here we stop with our here. This is the last question of the assignment. Okay, this is the last question from the assignment. The last question from the your assignment. So I hope everybody will get good. I think most of you get out of it. So not that difficult. Okay, so right now we will go for further study because of course 1 hour is left. So we will go for further study now. So practice set question for this semester, this week. So what we consider that is from first we have 1 to 5 lectures for week 1 to week 2 and not week. And right now we will have 5 to 10. Okay, for week 3 and week 4. What I am covering actually will be 5 to 8 will be for week 3. Okay, and from 9 to 10 the 2 lectures will be kept for week 4. Okay, this right now we did week 3, so we'll go with for 5 to 8 lecture. Okay, 5th to 8th lecture we go with for question answer. If the time will not permit us, then we will go for 4th week, because there are nearly 50 questions, so it will take time to explain everything. So in what range of cutting speed in HSS milestone workpiece pair is the build up edge will form? Okay, you know there in the slides it is mentioned that it is some lower to medium range below the recrystallization temperature. Okay, these are the lower to medium case below recrystallization. We know this one. Okay, it is below recrystallization. Okay, below recrystallization temperature. So what it will be? But it's lower to medium speed. Okay, not up to discontinuous cheese, and that concept we are not considering. But below recrystallization temperature, it is sufficiently medium. Okay, so what it will be? It is given in the answer in the slides that for this pair, uh, you know the answer. Okay, 18 to 20. This will be the answer because it is in the slides. It is actually the research part. So why it is happening? Because the temperature will not be happening up to not be reached for my speed. So due to because it is less, the recrystallization temperature will not be reached. So for my steel, will not be reached, in this case. So okay, so will not reach. So this will not reach in this case, due to which the this will be a correct answer. In this case, this might be reached. So the buildup is not form, and here it is far below. So depending upon the conditions now, maybe form, will not form. Okay, because mild steel, so build up is again depends upon that. Mostly it will not form here. Mostly or depending, mostly it will not form here. Because of poor material condition by steel ductile, so continuous chip will form definitely. But continuous chip would increase the rate angle, then might be possible. Mostly mild steel this will not happen mostly. But build up will not definitely form. Depending upon condition, it will happen. It will happen because rate angle again came into the picture. So this will be depending. Mostly uh, will, will be continuous only. Ductile charge is very less, will be continuous, but without build-up rate. Here it will be quick build-up rate. What is the question? The build-up check lead cap. So those it must be the middle part. It is lower middle part where the temperature is still below recrystallization temperature. We have build-up into okay. So this is will be the answer. This is something a lower middle pair and this higher pair. So this is here the build-up is will not form. Again here we will have only this range the build-up will form because the temperature and pressure conditions again need to be favorable for this. So what is the temperature and pressure condition which is available? So temperature and pressure condition need to be favorable for this. So for these cases, your temperature and pressure. Temperature mostly force basically. Force or pressure, stress. Yes, pressure means what? Activity or stress. Okay. So stress and the temperature condition, both these conditions will have to work to determine the pitch. And there is no reflex. Okay. If the temperature and the machine reaches above equalization temperature of workpiece material, will build up a steel form. So again, this will depend, is not a concept. Depend upon room pressure, room temperature has nothing to do with it. Okay. So the starting will get at this temperature will be directly cancelled because with room temperature there is no parameter at all. So the answer is either yes or no. what we are talking above recrystallization temperature means it is soft now. Okay. So as it is soft now, buildup is will not form because material is getting soft or stale. Again, recrystallization means a regrain will form. Okay. The grains will be formed again. So due to which the material becomes softer and which due to which it will flow. It will flow and the welding will not happen. So yes, buildup edge will form. The yes is not answer. Correct and not correct answer because buildup edge will not form and the no will be correct answer. Right? Buildup edge will not form. Okay. Buildup edge will not form will be the correct answer. Okay. Because it will not form because it is above crystallization. It will be soft and it will flow. Okay. And it will flow, it will not provide up and this no will be the correct answer. So this is the correct answer. No. During the machining operation, relationship between the temperature generated and the cutting velocity is, you know the relation, the square root, you know the graph, how it is going actually. Under this is temperature, that is your theta, okay, temperature, and this is your cutting speed. Like this. So theta will move up C into 1 by 2. Okay, this is relation, correct? Temperature. This is due to this only you can tell that it is reaching due to certain temperature not due to this curve. Okay, so we'll get a buildup which will form apart from this equilibrium itself. Okay, you can get what might be the range, so we can get how that answer 80 to 110 will come from meter per minute came from. Okay, we'll get everything answer with this equation. Then it will put means if we calculate completely this proportional size. You need to add constants here. It's not the actual answer. Add the you know to give the proportional design. You need to add constants. You know this one. Okay. You add a constant here. Some use something constant, and you will get you can get this value. How? Oh, what is can yeah. Okay. So 82. You will get from this how the 82 to 120 you will get because of this temperature increasing with you know this how it equal. The temperature and cutting speed increasing. Okay, so how it is in the table? By this graph is shown here. So this is able to the table and we can state whether the crystallization temperature has been reached here or not. We can state from here. Okay, we state here that we will reach or not. And from it we can get where to build up will form or not. Okay. Or temperature simply what? Will the temperature we will get from here. Okay, this is the correct answer I told you. These all are like numeric terms over here just to confuse. But this will be a correct answer. You can remember that you can't derive it anywhere. You can remember it. You will not derive it anywhere. You just remember it as. During the machining, if cutting speed is more than crystallization temperature of the workpiece material, the chip form will be okay. B will be the correct answer because more than the crystallization temperature, I already told it will flow. Okay, in flow, material will flow and it will be so it is flowing. The buildup edge will not form. Without the buildup edge will be correct answer. Continuously without buildup edge. Okay. Without buildup edge. This is such a temperature will be super very in the cutting speed. Okay. So as the crystallization temperature is reached, without buildup edge will be very important concept. Okay. Continuously without buildup edge because it will not have a buildup edge. This is wrong remark. So this will be not the correct answer. must be without filter page. How filter page is formed? So we will be continuous without a filter page. Without filter page will be correct answer because the filter page will not form because it is above registered addition temperature. It is more than that for required temperature. Your preferred sheet column will be without a filter page. Okay, I already told you, it must be without filter page. In given figure, X stands for which plane ASS system or two nomenclatures. We know this will be your longitudinal plane. This will be your base plane. This will be your transverse plane. Okay, this will be your transverse plane. This will be your base plane. This will be your transverse plane. And this will be your longitudinal plane. It's very simple. You need to understand that this what plane it is. Just longitudinal plane. It is how it will work. It is longitudinal plane. This is how it is defined actually. Okay. So no explanation because it is how it is defined. This definition. Okay. Why back rectangle is not considered in ORS2 nomenclature is not important. Is not correct answer here. It does not take part in machining. Is take actually so this is the wrong answer. Orthogonal rectangle is an inclination angle will describe the black angle. So this is a left angle because both of the angle will describe the angle. So we know inclination angle and our backward angle will completely describe this sufficient describe sufficiently describe this angle. Okay. These are the sufficiently describe this angle. So in those cases, it's not required because it's sufficiently described. Okay. So it is sufficiently describing now. Sufficiently described. Okay. Sufficiently describing backward angle. The your backward angle. Okay. What orthogonal rectangle? It's the orthogonal rectangle and inclination angle because we know what is here orthogonal rectangle. Now we don't have right angle. Okay. Orthogonal rectangle and inclination angle is there. These will automatically describe your backward angle. So we don't use backward angle. Okay. Because it is sufficiently described. You can use formulas to get backward angle. So this will completely describe your backward angle, but it will have also additional information. So for this gain out of it. It reduces the accuracy in equation. Is the wrong answer. So only this will be the correct answer. Okay. Ordinary unit sufficiently describes the backward angle. Okay. So that's why I use this. Because it will describe so there is no way. We can omit it. Okay, because already get what will be the answer we get from both we will get the answer. Okay. Of this. Then I will get answer for this. So what actually we can get actually what it will be by what will be by from both. Or through the rate we get both. So we not use it. Okay. Because we get this or we will get this answer. Everybody for this. And for that we get more information also. How the chip will flow that we get. Okay. So where the chip will flow we get from this inclination angle. So that we get more to describe it completely. So we don't need it. Okay. We will omit it. That is correct answer earlier. Okay. I already mentioned this is your correct answer. Okay. In a given figure of ORS tool nomenclature, the X stands for. Okay. Here we are mentioning what is this X. So okay, you know this is your inclination angle. You know this is not auxiliary angle or anything. Inclination because from the geometry we will know what kind of angle it is. This is inclination angle from the geometry itself we can know. There is no any further description required. The figure is like that only. If you get the way this is curved, so you get its inclination angle. Okay. You will definitely get this indication from the geometry itself. Okay? You know, because the geometry itself is described in such a way, so we will know what it will be. So it's simply a inclination angle. Okay? It's an inclination angle, a this angle. Okay? For geometry, it is not any frank angle, it is not any orthogonal angle. Rake angle is different, it is not orthogonal. Inclination angle. Okay? From the geometry, it is very clearly visible. Clearly, it can be understandable, can be diagnosed very easily. That is the, but you need to find know the answer that is the case. So this is the inclination angle. Okay, this is simple because yeah, from geometry we get there is no further explanation. Geometry we get because the way it is deformed. Okay, so this is called as your inclination. So the what we go to have inclined. So how the chip will flow we get from here to inclination angle. Correct. Okay, inclination. So how the chip will flow we get from this. The way chip will flow after removal. So we get from the inclination. So this is your inclination angle. Okay. This so it is mentioned two standard definition to get how the chip will go introduced in orthogonal system. That is just where it will be, how it will be. So to get the answer at how where it actually located, so it's where it's located from geometry is clear. So it is geometry also choose for in that way only. Okay. So if the cutting plane edge angle is YP is 40 degree. Okay. Then side cutting edge angle. So this is in ORS. This is in AC. Okay. We know that relation. Our YP it is in ORS. Okay. Our YP is in ORS. Because this angle in ORS it is done x-axis. Okay. Here this angle is done with x-axis. It is done with x-axis. No respect. And here it is done with y-axis. So no again respect. So these are with x-axis. It is done with y-axis. So both of these angles are actually from here. Yeah, somewhere here. This will be your ASRS, your cutting side cutting edge angle. And somewhere here it will be your X. Something here. And somewhere here you have X angle. So summation of the both to minus it actually, which will make some angle with here and here. This is with Z and this angle with X. So we know this relation that YP is equal to 90 because it will form a 90 angle triangle and it must be difference between must be 90 because it will form 90 degree here from there because here this will be the angle. Okay, and this if you draw a line parallel to it, so where is my cursor? Okay, so we line draw a line parallel to it. So it's simple. We line draw a line complete parallel to it. So both of these angle will be equal. Okay, and this will be your 90 degree angle. So both that is YP plus YS will be your 90 degree angle. So what we have? We have YP plus YS. So must be 90 minus 40, 76 will be your answer. Okay, from 40. 90 minus 40. You know, when you go to this geometry, it is with red axis, it is with y axis, it is x axis. Due to this will form. Okay, this angle will be your 90, and this is actually the plane is not being guided on different angles. So like this, but this will be your 90. Okay, this will be good at angle, and this will be complete 90, and this 90 degree and this angle, this will be your 90 degree angle. Okay, this will be your 90 degree angle, and both are the YP and YS were given. So simply 90 minus 40 is 90, 76 will be your answer. Okay, okay, you know this. What are the set of angles are considered in two nomenclature? So what angles will we consider? We know there are seven things. Okay, so this, and there is a node radius. Okay, so what is your node radius? So this will be seven probably. we are asking here what set of angles are using for nomenclature. We know the radius is there, so it will be omitted for the part of most radius. So we know this part we will know that is no radius. We know with this part of no radius. Okay. So as you omit this part of no radius, because we are asking here for angles, not for anything else. So we know last is no radius due to nomenclature. So so this set of angles what we have, you know, first rake angles have first two rake angles are correct. We have there set of flank angles are again here, and set of cutting edge angles are this last one. So we have all of them. So all of the above will be your answer. Okay. So this is the answer. All of the above. In ORS and NRS tool nomenclature, the base plane and cutting planes are. What is cutting plane and base planes are? Same. How it will be? What changes? Just normal. We can use this normal to the cutting edge. Here it will be go from auxiliary edge, orthogonal cases. But here it is normal to cutting edge. Yes, so it's slight difference. It is normal to cutting edge, so it will be slightly different. So as it is normal to cutting edge, that's why it's slightly different. Why it is going from that auxiliary plane. No respect. Okay, and okay. So the base planes and cutting planes are same. Okay, base planes and cutting planes are same. Only the auxiliary angle to plane that is third plane is transfer plane is different. Where is a normal plane? It is orthogonal plane. Normal plane is cutting perpendicular to velocity, not velocity, so cutting edge. Velocity different. Velocity is discrete time. So velocity don't have picture here, but orthogonal will be something like if you go from auxiliary and normal will go to perpendicular to cutting edge. Okay, but it is not a concept here. What are the same? What is the base plane and the cutting plane will be same. So we are not cutting edge. This is the cutting edge. If only we are cutting edge, and it will go somewhere from here. Your normal angle also goes somewhere from this normal actually, but your base angle will be same. That is the case. It is where the angle is normal to the cutting edge. Orthogonal it is going from this. This is not normal actually. It's some because upon depend upon the angle. Side cutting edge angles, other angles, side this side, yeah, side cutting edge angle. This is main cutting edge angle. This is end cutting edge angle. Side cutting edge angle, end cutting edge angle. So it will become end cutting edge angle. And here it will depend upon it is normal. So you will change that angle will change, that transverse angle will change, but your base plane and the cutting plane. Okay, base plane and cutting plane will be same. Okay, this will not change. The normal angle outer plane will change, but base plane and cutting plane will be same. Okay, this is the answer. It will be same. Mention it. Okay, it will be same. What will happen if the backrake angle is 0 degree? So backrake angle is 0 degree, which is actually your inclination angle. Okay, if it is 0 degree means from this also you will get the answer. This is simply inclination angle. If it is 0 means it will flow parallel to the workpiece because it is parallel to the workpiece surface because it is 0 degree. It will go like this. So our workpiece is going here, our workpiece is here, so it is like it is moving here from here. So what this is our workpiece. It will move parallel to the workpiece. Okay, because the angle is 0. This is your inclination angle. And so the geometry also. The acrylic angle is again angle both are the same. It is both are same. This is inclination angle actually, but both are same here. Both not both are same, but both mostly give the same concept you are using, or it can be acrylic angle or inclination angle. Both can be considered as same because it is following the simple inclination. They're not solving the same because we're having some different kind of concept, but that actual problem, but slightly different. But this basic concept will be same only. Okay, what will happen if the backward angle is 0 degree? Okay, basic concept will be same. Backward angle will be 0. This will be a place and it will plan. Away from the workpiece is not possible. It is not good. Away from the workpiece, it is not actually. It is away from the workpiece that outside concept, but when it is 0, it must be go parallel to the workpiece. So it is whether it is away from the workpiece or not away from the workpiece, that concept we are not considering here. Because then we have to watch the workpiece away from the workpiece, but parallel to the workpiece because the zero right angle. So zero inclination angle is here because what you are asking backward angle is zero, then what will happen? So this will be your correct answer according to the question that is asked. Okay, we are going with what question actually is asked. So according to the what question here is asked, will flow in parallel to the workpiece will be your correct answer. Okay. So because it's a show the result. Okay. This will be the word chip and this will be your inclination angle and how it will go. Simple. Because there is no actual because this angle is not present in here. So what will be your geometry? Like this. Okay. This is your actual geometry when it is zero. So what will happen? Because this angle is zero. Zero angle is this will okay. So we will go parallel to the workpiece. That's it. So you will imagine just the mostly based on imagination. So how cutting tool will have. So mostly point it will flow parallel to the workpiece. Because workpiece is from both the sides. Okay. So it's parallel to the workpiece. Okay. Parallel to the workpiece. Because workpiece is from the both the sides. So both the sides is from the both the sides. Okay. Both sides and two sides should be there. So I'm going to chip. Okay, this is your case. And this will be your okay. So you do two things. Here also you are cutting something. Here also this is both you are cutting like this. Here both you are cutting. So it is moving parallel to the workpiece because this moving like that. Okay, so it is going like that and the chip is going in the opposite. So it is parallel to the parallel but opposite direction. That's it. But it is parallel to the other. Okay. Larger the rake angle, what you are asking. This is our rake angle consider. This angle is large. Anything. So with a large rake angle, definitely cutting force will be high. No, it will be lower because edge will be small. Okay. But you can infinitely small. You know this because the rake angle this only will be the edge will act because you are using a high rake angle. Okay, this is how chip will flow. The professor say ask said in that day. Okay? This is how chip will flow and the area, the shear area will be less due to which the lower cutting force is required and the power will be low because surface finish will be available. Okay, because it will form so this continuous chip will because with the large rectangle this continuous chip will form and the surface finish will be good here. Okay. Large rectangles because it has more time to flow, so it will be mostly continuous and the surface finish will be good because of the continuous large rectangles. Large rectangles it is very area and so it will have more time to flow. Okay. So all of the above both are correct. Finish also good, power is less, lower cutting force. All are correct. All of the above. Okay. So this is your correct answer. All of them is your correct answer. With increasing rake angle, what will happen? Decrease in cutting angle between the rake and principal point faces. And that's correct. Less control level to support to because you're increasing the rake angle. I already said, show you. Okay. So this is the increase the rake angle. Decreasing with conduction. Yeah, all of the above you are in the correct answer because everything will happen. So the angle between the rake and the principal raised face and the principal flank face. So angle will be decreased because of what? Simply because of what? Okay. Because of what? This rake angle. Okay. And releasement will happen to support material again. Here the area is less. Support material is less. And due to which the conduction, there will be thermal deformation and the conduction will be less. Okay. This is the case. All of the above will correct answer. Okay. So take a rake angle. The rake angle usually vary 18 degree for a single point axis tool depending upon the work material. Rake angle. Okay. So 1 to 5. The normal range is 5 to 15. No. Rake angle must not be infinity because we know the problems we solve from 2 to 3 questions. We saw the problem due to large rake angle. So it can be large. Okay, so 46, 56 degree will be directly cancelled. 5 to 2. 1 to 5 again is very small. It will not cut. So this will be the appropriate answer. This is the correct answer actually. It is not the appropriate, it is correct answer. Okay. This will be the correct answer. Okay. Okay. Let's show here. This will be the correct answer. Why? Appropriate cutting edge angles are provided. We are working cutting edge angles to reduce friction, to reduce temperature, to reduce chatter, and to reduce surface roughness. See the problems, see the options correctly. Here we are talking reduce, reduce, reduce. See the options. Reduce, reduce, reduce. Here we are increasing. So increasing surface roughness means downgrading surface finish. So it is never considered. So in reduced temperature, there is no role of temperature here. Reduced friction, no role. Only role is chatter, vibration. For proper angle, the chatter will be less. Okay. Vibration, that is self-excited vibration. That is what chatter. So this chatter will be less. Because it is self-originated. The source lies within the tool. So due to it, the chatter will be less. Because of the application for this, reduce temperature and this is the concept of power, not proper cutting edge and provided to reduce the chatter. It is the most appropriate answer. Okay. From all the answers we have, these are ways mostly to reduce the temperature, to reduce the friction. This is not here. To reduce the friction, what is the cutting edge? And to temperature reduction, this is because of the power again. How much power you are putting. So chatter reduction can be done by using this, so this is the correct answer. Okay, this will be your correct answer. So, surface roughness is we are decreasing the surface roughness actually. Surface finish. Surface roughness is equal to surface roughness. No. So we are increasing the surface roughness. Yes. We are actually deteriorating our face. So it is problematic actually. It is not good. It is more problematic. Okay. This problem. So it is not considered. So what we will do? We will go with reduce this option. C option. This chatter. The appropriate value of node radius is selected to resolution is more than correct. More than one correct answer. To improve improve life is correct because the chatter will be given. Reduce surface roughness again. Surface roughness is mentioned. Means increasing surface finish. Okay. Roughness is absolutely finish. Increase cutting force is not and chatter is wrong. Okay. So only two will be correct. Improve to life because it will reduce the chatter. No, it will reduce the chatter. Okay. It will reduce the chatter. So it is proper to reduce the chatter. It reduce the equal to life. And the finish because if it is appropriate, you are saying appropriate, not anything. Appropriate. Why? Improve life and reduce surface roughness. I will get surface finish. So that's it. But focus on what you are feeling, roughness or finish. You have to focus. Okay, the roughness is actually the when the peak and value that you have roughness. Is what roughness. And finish or the surface finish is smooth actually. Okay. Surface roughness is increasing means we are increasing peaks and value. We are using surface finish means we are making decreasing the peaks and value. Okay. We focus upon the finish and the roughness. Okay. Here both will be true because it is release. Both will be true. Okay. So this both will be true. Which of the following is not assumption for merchant circle diagram? Tool is sharp is correct. Information tech is again this is called as actually this is called as very thin zone. No, it's specifically called as very thin zone model. Okay. You know the merchant circle is called as very thin model. You know this part. Okay. This is called as very thin model. So this is the very thin model. Okay. And cutting edge is parallel to cutting velocity. Uh, yeah. Coefficient of friction is constant. Is incorrect. What is the problem over here? Is constant is okay. What is the problem? Parallel. The cutting edge is cutting edge is parallel to cutting velocity. Cutting velocity is this. Cutting edge will be like this. Again, this is in oblique cutting. This will be case of oblique cutting. Because right now we are going with alcohol. This is oblique cutting. And right now, if you go with merchant circle, it will be like this. Edge. It's perpendicular to the edge. And it will be easy. So this is wrong. Yes, this is your correct answer. First, we are asking which is not the assumption. Okay. What we are asking here, which is not the assumption of merchant circle diagram. So what will be this will be your answer? Is it? Yeah, sure. This will be your answer. Why the cutting force and thrust force are considered in merchant circle analysis? So it's slight tricky question you need to be very focused on answering such kind of questions. So in case, what is happening? This will be the correct answer. In case of change, this the professor showed there that shear plane angle and rake angle of the rake will change, but cutting force and the thrust force will not be changed. So it is always perpendicular parallel to this is the cutting force, cutting force and thrust force. Yeah. This is always parallel, not the same. Or same. This for me should only is correct. There is to be for this is correct. Here we see, and this is the thrust force. This will not change. It is always parallel to the what we say. What may be your angle in case of shear plane and rake face? These things will not happen. Okay, so with the rake face and with the problem of in the rake face and rake angle, sorry, rake angle and changes rake in the shear plane, the other forces will change, but our cutting velocity or cutting force and surface will not change. So it is always parallel to the VC. So it's parallel to VC will not change. So your whatever VC and plane angle, correct angle, so other forces will change, but your cutting force will not change. That's why it is implemented in multiple analysis. This will be your correct answer. Okay. For simplicity is known as nonsense. In this case, it is cutting force. Maybe force the in case of changing cutting force and thrust force, the other forces will change, but the shear plane angle and the rate phase will not change. So it can change. Simple. It will change. It will change. Okay. The angles will not change. Is wrong answer. Okay. It will change. It will definitely change. This will be correct. So which is cutting force. So why we consider the reason behind it will be this one. Okay. So we must consider why what we are asking simply why it is considered in this analysis. So why it is considered in this analysis that is cutting force and why we are actually working with this analysis because of this reason. because it will not change. With the change in shear angle and rake angle, it will not change. That's why we are using the rate. Okay, that's the answer. Now let's show here the right answer. Okay. You can be moving the chip thickness ratio will be a bit. So what is chip thickness ratio? No, is T1 by T2, which is equal to uncut chip thickness divided by chip thickness. Uncut chip thickness divided by chip cut chip thickness. This is uncut. This is basically cut chip thickness. This is uncut chip thickness. So it will be always less than 1. This is some point because our chip will expand. You know the concept because it will more temperature will go on to the it will again carry the temperature. You know, chip will carry the temperature. Okay, it will carry the temperature due to which what will happen? It will expand. Okay, as it will expand. Okay, as it will expand, what will happen? Its T2 will be increased. So its chip thickness. What we are asking chip thickness ratio. Thickness will go on increasing after cut. Okay? After cut chip. So what we are having T1 that is uncut, it is less and it is more. So what we are dividing less with more. So answer will be always 0 point something. Okay, it is less than 1. So less than 1 is the correct answer. Less than 1 and we are again asking you what is normal range. So that problem also we considered. So it's less than 1 and what we use answer range, you know, is less than 1, everything is wrong. This can be both, this can be correct, but it is very small. Okay. This ratio point also it's very small. So this is the correct answer because this is less than 1, so this should directly go on top. Okay. We know this directly in this. Okay, so out of which this will be a correct answer. You know this will be a correct answer. This 0.5 to 0.6. Okay, so right now we'll go with problem sum. Find the inclination angle if principal cutting edge angle is 75 and metric angle is IP. You need to find the inclination angle. You know the formula for inclination angle. So if you can find the formula for inclination angle. So the things will be go slightly different because here the formula is same. Okay. So what we have given over here to see what is given. You could write start with like what is given over here. So what is given? Inclination angle to find out. Okay, so cutting edge angle is given. So P is equal to 75 degree. Right leg angle is alpha P is equal to 80 degree. Your phi is equal to 15 degree. So what will be your answer? You to know the formula. Basically, what will be the formula? Tan I is equal to because you have to find the inclination angle. Okay. So your formula will be tan I is equal to sine of RP, which is a principal cutting angle, into tan of YP. Okay. This is a backward angle to cos of Y. That's IP to tan of Y is a symmetric angle. You know, so to put the answers correctly, that is sine, you know, it is 75, tan of 5, we need to find what is 5b, 8 degrees Celsius, okay, minus cos of 75 and tan of 15 degree. Oh, you know, 15 degree, tan of, what is this tan of 15 degree? Yeah, tan of 15 degree. What do you mean? This? Yeah, tan of 15 degree input, call this. Input is equal to just find out the answer. You will have something that is what I'm getting here 0.0664 tan I. So I will be equal to tan inverse of your 0.0664 and that will come up to 3.6. 798. That will be your answer. You can what will you can correlate it to? You can equal to 4 d. So what it will become 4 d. So 4 d will be your answer. Okay. Mention here 4 d will be your answer. Okay. To find the orthogonal rake angle if the principal cutting edge angle is 78 degree and the back rake angle is alpha b. So with and the phi is given. So what we need to find? Orthogonal rake angle. So we need to write down what property we have, what we have to find out. So what right? What will be right here given? What the problems we given? What the things we given here? So given here will be phi. What are the things given here? To forget what the things are given here. Simply asked. So RP, your principal cutting edge angle is 70 degree. Your back rake angle is 10 degree. Your side rake angle is equal to 12 degree. Okay, what they asked, find can write like that also. Do not NPTEL you have not written at all. Just NPTEL question, but NTA it will help you to get in your BTEC also it will help you to write answers like this strategy. That's it. Alpha orthogonal is asked because we are changing to what is this? We are changing from ASA to ORS. Okay, this is what we are using because we are changing from ASA to ORS. From ASA to ORS we are changing. That's why we are using this concept. Okay, so we must do the formula for this again. So we know that tan alpha O, which is your orthogonal angle, will be sine RP into tan phi s. Recording or not? This is recording or not? To check because this you need to submit. There's nobody is using. So yeah, tan. So what is this? Okay. So keep it. So what we do? So not okay. So here press this and keep it here. Okay, and then what we do? Go okay. Plus check whether it's recording or not. So cos your principal cutting edge angle into tan of phi p. Okay, so simply just put it sine 78 into tan multiplied by phi is 12 degree plus cos of 78 into what is my tan? What is here? So it will be tan of 10 degree. Okay, so what will be your answer here? 0.24457 will be your answer, but it is tan 0. So what we will do to get tan inverse of 0.0, how to put it? So this simply will be tan inverse of this value. This is 24457. Okay, so what we will get here is equal to 13.74, can be round out to 40 degree. Okay, this will be your answer. Okay, this is your answer, 40 degree. Okay, this is how you can solve it. So find the normal rectangle. Now what we are doing over here, you know, we are going for normal rectangle. Means what you are doing, what you have, orthogonal rectangle is given. Inclination angle is given here. This we are in ORS now. We are going here tan RS. That is non-merging angle system. We are orthogonal angle system, non-merging angle system. So how we are mostly working rake angle. So this is simple problem for rake angles only. So what we do, we know this was need to find out the formula that what it is asking the orthogonal rake angle are fine. It is to find. But what we have alpha u we have 80 degree this 10 degree, not 10 degree. So we will 10 degree. What is my inclination angle which is given over here? I will be 80 degree. So we must know the formula. Right now we put in formula, we know the formula. It is tan phi n because we have to find phi n value. Tan phi n which is equal to cosine the inclination angle into tan of tan of phi o out of the angle. So just put it over here. It will be cos I means it to into tan of that is phi of 10 degree. So it will be directly equated answer. So the answer will be simply this answer will get simply phi b inverse of this answer. The answer will get over here and the phi is actually 0.17 degree. Because it tan 0.78 is not actually 0.78 is this answer. If you take inverse, I think I have not taken the inverse. I think I have not taken the inverse. So this will be your answer. So this will be 0.1746. What you have to do? Take a tan inverse of this. It is 0.1766. Take this tan inverse because it is free tan, so we will take a tan inverse of it. So we type the tan inverse of answer is equal to 9 point. The answer will be 9.90. 9.90 degree. Okay, so your orthogonal ray angle will be 9.90 degree. So the calculation will be simple. Okay, you can change your answer there. Okay, because I think I put you put correctly. Oh, what I put? Oh, it's wrong. Let us see. This is not answer. Actually, the answer is 9.90 degree. Okay, this is the correct answer. I don't take the. I haven't taken the part. Okay. So we solve the answer over here taking a tan inverse of this phi n. So which means the answer will be 9.90 degrees. Okay, so we go with 44 question now. Since then now we go to inclination angle we need to find. Okay, orthogonal angle is given. So we have the orthogonal angle is given is 18 degree. Okay, and your phi n is given which is 30 degree. So we know the formula actually. Okay, what is the formula? Correct is tan phi n because we are going with normal rake angle and we have orthogonal rake inclination angle. So you must know the formula is simple. That is, you know, must remember all these formulas. Cos I into tan of phi u, which is orthogonal rake angle. You have to find this cos I. What will do? Tan phi n by tan of phi u. Okay, so this is equal to cos I. So it will be tan of 13 by tan of 18 degrees is equal to 0.7105, and what we do, simply do cos inverse of this also. So cos inverse your I is equal to cos inverse of 0.7105. So what will be your answer here for I will be 45 because it is 0.45 degrees. So it is mostly under 2 because 45 is 0.2, so it is 7.7. 0.5 is 717 something. 71747 714 okay, 7141 is the answer here. So it is 45 degree angle of cos A. Okay, so I have mentioned here the angle is 45 degree. Okay, okay. So calculate the shear force, which is rounded out of it. Okay, and something answer will be something more or less basically 741 will be different answer. For root 2 the answer it will be like that. But close to root 2 means close to 40 because you have to find again in forms of some real integer will be given. So what you will be doing because you will need to answer without even taking the cos inverse, you can directly find the answer. Okay. In calculator, you will directly find the answer by this concept loss. So simple logic only. Okay. Logic, simple logic. This is first 45. So so calculate the shear force for least machining power if width of chip is W is given there. You have to find what things are given over here. Okay. So W is given over here is 2 millimeters. The uncut chip thickness, that is T1, is again given over here is 0.2 millimeter. Shear strength of the material PS is given 500 megapascal. Okay. The rake angle is given. Rake angle is 0.5. Okay, coefficient of friction is given. No is given. Which is not 0.6. Okay. So from that, what we will get? So what we need to find here? What is the formula for this? That is more important. To first find the formula for this. We need to first have a formula for this. So what is the formula for Fs? Because you have to find Fs only. Okay. Shear force. You know the formula for this. This standard formula in Ts divided by sine phi. Okay. So what we have over here? What is the thing that we have? W we have. So W we have, yes we have, P1 we have, yes we have. They can go we don't want, we don't want. Yes. But we what need to find a file. Need to find a file. Okay. We need to find a file. So, what we have, so phi we have. Okay. Phi we need to find out, or we need here because we don't have phi. Okay. Here we need a phi. We don't have phi. So what we given here for least machining power. Okay, what is mentioned here for least machining power means it will be Mercer equation. Okay, it is based on least power. What is that equation? You know, it's 2 phi plus theta minus the rate angle is equal to 90 degree. 90 degree. So you have rake angle. Even which I did it from aircraft. It is rake angle. Okay, we do something. This is rake angle. This is your rake angle, and this is rake angle, and this is given the rake angle you have. Pi you have to find out, and beta you have. Yes, you have this. So what is that? Tan inverse of mu will be your beta. You know this fact. So what will be your beta? You need to change your page. Yes. So you know what will be your beta. Your beta will be tan inverse of this mu. So beta will be simply 31 degree. Put it here. You want pi. So it will be 90 plus what is your they can get 10 minus 31. Okay. So this is the case. Plus 10 minus 31 divided by 2. So what it will 69 by 2. So it will be 34.5. Okay, so right now you got everything. What you need to do, just put it in a formula. That will be your answer. Okay, just put it in a formula. So you know that Fs will be equal to W, everything you have. You got the Ts now. 5, so you have 5 you got right now. So it will be 2 into 0.5 into 500. You know everything. And sine 45. So for 45 you just got answer. It will be 35. You to the answer you got first. 35, 34.5. It's not 45, 34.5. Okay, so you will get 882.758 Newton to be precise answer. You will written over here. Okay, just see how we go. We will go for 50 something. Okay, you know the answer. Take care for that only. But that's all there only. So 58 will be your answer. Okay, this will be your answer. Okay, so this is just for a blank slide for these two calculations. So calculate the shear strain if G formation for least machining power. Then we are using least machining power because mostly it is least machining power only. But for no confusion, I am just mentioning. If it is mentioning that you need to go with what it is called as strip line field theory. What the last question it is there. By using strip line field theory. If it is asked by using strip line field theory, then it will be different. Okay, we have to apply the Shepherd equation. But here, mostly we go with distribution power only, which is sorry, equation. Okay, if the field of the chip is given, it is given to this color change uh, 2 millimeters. It is given. Oh, it's black. So the uncut chip thickness is given again. P1 is equal to 0.5 millimeters. And the shear strain material is given. That is shear is given for you is 500 megapascal. Okay, and the rake angle given which is 12 degrees, and the coefficient of friction mu is given. So we can find beta, immediately find beta. Okay, it's simply tan inverse of 0.66. So beta we get 33.42. Again, what is asked over here? Okay, see what we can call it beta. What is asked over here? Shear strain. What is the formula for shear strain? Okay, so shear strain like something which is related to not shear strain. It is this shear strain like this. It is this. What is not it is? Uh, Previous shear strain. Okay. So shear strain will be equal to what? Most of the formula here. What is your formula for shear strain? Tan of phi minus alpha plus cot of phi. Okay. So you know you have alpha, beta is unnecessary to calculate, but it will be asked. Oh no, they ask. No, this is given. If you want, you can calculate for other equation. Most of the time, if you club something else that we have solved afterwards, so we club with something else, so we will find better to get this find later. It's not that is not a much time consuming because first we have a so time find like and yeah. Okay, that we find that is not a problem. Time file you must know file you need to try to find, but I already mentioned you have a list machine power. Okay, so what is list machine power actually means? You know list machine power if you go to notation. So you know, oh, you have to find. Sorry, it is required na? Because you don't have file. For that file, you must know beta because you know alpha, but you don't know phi. You need to find it. For that, you need beta. So beta is not boosted. So beta you need to find out anyhow. Okay, so what will be that formula? You know 2 phi plus plus beta. So 2 phi plus beta minus alpha which is 90 degree. So we know again phi is equal to 19 minus plus alpha minus beta divided by 2 which is again equal to 34.29. Okay, so here we got this. So what things we put now? Tan of is 34.2. Oh, I did problem. So we will solve one more problem. Just I will end up just other problems I have used solve afterwards. Okay. So it will be tan. Could this not be corrected? Because we must select anything. Minus tan 40.2229. Okay. Same thing. Oh yeah, 672. Yeah, 229. Okay. Minus 5. What is your 5 equal to 12? Okay. So we can go to 12. Okay. So for this it will be 12. So we do plus multiplications. So plus anything. So plus anything will be for so plus so the plus sign quarter plus plus quarter 5 it is 34.29. So what will be answer? Will be 0.40099 plus also find the quad just take 1 by tan inverse of 34. So just take tan inverse mostly use the same answer. Okay. Because it is 1 by na. What is tan here? Tan is what is your tan? 1 by tan will be your quad. So just take inverse of it. You will get this answer in your calculation. Not to worry. Okay. So it will be 4.7 yeah, 4.7046. So it will be 5.1145. So we don't have any unit. Okay, it will not have any unit. Okay, you know this one. It will not have any unit because it is the rate shear. This same by same shear strain. It is strain. So it is same by same. So it will not have any unit to be cast. So this is your answer. So what is your answer here? 34415. So I have answer here 4415. Will be your answer. Okay. Need no need because it is strain. Yeah, this will be your answer. Calculate the got the answer. I think that's okay. We will record it. calculate the strain rate in chip formation if the workpiece with diameter 30 mm with 500 rpm with 8-degree rate and rate tool shear plane angle was found to be 78 degree and chip thickness to be 0.4 mm. So here what we need to find is again strain rate. What is strain rate? So you know strain rate which is equal to what is strain rate? Actually dot s by some dot t divided by 1 by dot y. This is your answer. What is dot s by dot t? Exactly shear velocity. So how you can find the shear velocity from this? Using sine rule. Okay. So for that you need VC. Can you find VC? Yes, you can find VC. How? It is given 3500 rpm. So what is VC? V pi T N, which is in meter per minute because it is rpm minute. You need to find it millimeter per no. This is millimeter. Why? Because it was 35 meter, so it's millimeter. You need to find it meter per second. So what will you do? Pi in these divided by 1000 into n will be 500 divided by 60. So what will be your answer? At the end, 0. Uh, your answer is 0.785 to reduce the pressure. That's why it has been okay. 0.753 meter per second. Okay, you got VC now. So what next you want? This is your problem. Okay. Right now, what next you want is your main problem. Concept. What next you want? You have VC now, but from this sine rule, what you can have? VC is equal to cos of the rake angle divided by cos of what? Phi minus rake angle. This is this you can calculate by sine rule. So we have Vs, this Vs, this we can have Vs. So what will be your Vs now? Cos of 8 divided by cos of 78 minus 8. What it will be? It will be 2 point. What it will be? Vs into Vc. So what it will be? So it will be 2.8953 meter per second. Please check it into 0.785 meter per second. Okay. What is this? Simply also because of it will get multiplied by into VC also. 0.7 equal to 2.27. Okay. Multiplied it by this 0.78. What will we get? 2.2737. Okay, this point will be repeated per second. And this will be further divided by, now you get Vs. So you know what Vs will be. Okay, so we know what is your Vs. Okay, so you get your Vs is 2.2737. Will be 2.2737 meter per second. Right now, what we need, find the shear rate. Okay, to find the shear rate. To find the shear rate now. Okay, plot for the rate. So it will be 2.2737 divided by what is your shear rate problem? What we are showing here is R. So we go with that R only. R will be like this. Okay. So this R will be, we know, into delta S by delta T into here into delta T naught. Yeah, into delta T divided by what? Into 1 by delta Y. What is that Y? So it is chip thickness. Okay, instantaneous chip thickness. This is 0.4. This is millimeter. Okay, check these things. These are the long. This is millimeters again. So your S here it will be simply divided by Y means 0.4 into 10 raised to minus 3. So it will be, let me just calculate it. 0.2737 divided by 0.4 into 10 raised to minus 3 is equal to 5, 5, 6, 8, 4.25 second mass. Because meter will get cancelled. You know the fact. The meter will get cancelled. And what we left with second meter, so to change the answer, this is 5, 6, 8, 4. Okay, this is your answer. Okay, you just save it, page notes, just save it, what you will call the time. Okay, so you just wait for it. So, you know, this will be your answer, okay, this will be your answer. This will be your answer, okay. You want to get the thing, so this will be your answer. So this will be your answer. Let's change the answer, okay. Just a blank slide. Calculate the shear plane angle analytically for full width rectangle 10 and chip thickness ratio of 2 with 0.68. We just kept fixing it. Okay. So what we have here, shear plane angle for full width rectangle 10 degree. You know rectangle 10 degree we have, and now chip thickness ratio is R will be 0.60, 0.68. Okay, it will be 0.68. Okay, so we must know the formula directly. There is a formula for this. Okay, what that formula is for tan phi. So to get answer for tan phi. Okay, so you have to get answer for tan phi. Okay, tan phi will be equal to, you need to find tan phi analytically. Is equal to your this uh, chip thickness ratio into cos of your phi. Cos of phi, uh, cos of phi, cos of phi divided by 1 minus your r, chip thickness ratio into triple bracket sin phi. Okay, close the bracket. So you have r and alpha. Just put it r and not alpha, alpha and phi. So I think I made a mistake. So it's already 7. So phi. This is phi, phi. Okay, it's phi, phi is not alpha, it's phi. Yes, corrected. I actually it's over 7, so I okay, so this is phi. So change it, just change it. No one here to take you. I am only here. You will cos phi. So what is my cos phi? So tan phi, the answer it will be 0.65, 68 into cos of 10. Okay, divided by 1 minus 0.68 into sine of 10. Okay, so take directly our fan phi is 37 degree. So this is the answer, and tan theta is actually equal to 0.7593. So from this you will get this. Okay, from this you will get this answer. If you already mentioned, I showed that 37 degree is the answer. Okay, last problem. After that we have two problems. So we will take it in the next session because it's already 7:50. Calculate the chip thickness ratio for tool B, take angle 15 and shear angle to be 30 degree. Okay, calculate tool rake angle is equal phi is equal to okay, not phi, and the shear plane angle is phi 30 degree. Okay, so what need to calculate R, your direct formula, that is sine 38, that is phi. Okay, then we sine phi divided by cos of phi minus alpha. So it will be equal to sine phi is 38. Okay, so it will be cos phi 38 by minus 50 degree. So let's find out the answer because I think I put something else here. So sine 38 divided by cos of 38 minus 50. Okay, it will be 0.6688. That's the correct answer. Okay. Yeah, 0.6688 is the correct answer. And it is chip thickness ratio. It does not have it. That is the answer. 66788. So I have further two problems I have, or three problems I have. We will take it in next session. Okay. We will again add some more problems here and we will have other sections. Okay. So, this is the end of everything. So we are coming at the end of our last section. Okay, so thank you for um, watching this stream. Okay, so we now off the stream. Okay.